Welcome to July 4th's LeetCode challenge. Count vowels permutation. Given an integer n, your task is to count how many strings of length n can be formed under the following rules. Each character is a lowercase vowel a, e, I, o, u. Each vowel a may be followed by an e. Each e may be followed by an a or an I. Each vowel I may not be followed after another I. Each vowel O may only be followed by an I or a U. Each vowel U may be followed by an A. Since the answer may be too large, return modulo 10 to the 9 plus 7. Alright, how are we going to go about solving this? So, we're given C n values. That means that we have we need to make possible strings that are made out of all the vowels. So that would be the output would be 5, being A, E, I, O, and U, because you have n of 1. However, you have n of 2, you have 10 as an output, because the permutations, according to these rules, you have 10 outputs where it'll follow these rules, having a length of 2, a string of a length 2 vowels. Likewise, there's the answer for 5. So we know that the constraints are between the number of vowels are between 1 to a very large number. If we look at the hints, it's to use dynamic programming, which we're going to do, make an array if we need to. This also give a recurrence relation between the vowels as well. So let's go, let's break down the rules a bit here, and we'll see what we can make out of it. So we know A could could be followed by an E. We know that E could be followed by an A or I. We know that O can be followed by an I or U. We know that U could be followed by an A. And we know I can be followed by everything except for I. So it cannot be followed by an I. So everything else. So it would be A, E, O, U. O, U. So that's the relationship we have between all the rules broken down into some kind of directed type graph here. So we know that these vowels can be followed by any of the following order. So if we were to say make this into a directed graph, so having A, E, I, O, U as our nodes, and we were to draw arrows going from A to E, and E going back to A, and also E connected to I, and I will be connected to everything else. So we can kind of think of this as a directed graph, putting the rules into layers of the directions, and then we're going to connect them all together. So that's how we're going to approach this question, creating kind of like a finite state machine, you know, things are all connected together and start a graph, and that's how we're going to approach this topic. All right, so it just says to mention I mentioned to use dynamic programming, so we're going to do that. I would think to use dynamic programming from a bottoms-up approach, and let's see how we go about doing that. So let's first define our nodes, right? So the minimum they could be is 1, so it'd be 1A, 1E, 1I, 1O, 1U. So let's do that. A, E, I, O, U is equal to 1, as assigned to be 1 at the beginning. So we initialize our initial strings here. Next thing you want to do is let's probably grab the modulus 10 to the 9 plus 7. Let's call that mod 10 to the 9 plus 7. Alright, now that we have that, let's go through our go through the number of n's we have. So let's start building up our permutation. So for let's see, for vowel, I guess, in the range of 1 to n, we're starting from 1 because we already have a base there. We're going to update our vowels. So it would be a new, I guess, assigned to be. So we follow the rules we had before. I should have left them up, but let's see. A could be followed by an E, may only be followed by an E. So what we want to do is that we want to let's see. Update our count. Alright, so we know that the only time we can have A is when you have an E, an I, or a U. So we're going to do the counts of that. So we have to count the numbers of vowels preceding the current value. So we know that E plus I plus U is going to be equal. So if these values are, if you have these values, the new A would have the count of these, because these are the possible letters that could be, that points to A. And we're going to return the modulus of that as well. I'm going to do E new would be, so things that follow that are connected to E would be, let's see, so you know that A follows an E, may only be followed by an E, and we know that I could be followed by an E. So A and I, so it'll be A plus I, and we take the modulus of that as well. And we do new I, which would be things that point, that have an I in them. So not this. So E could be followed by an I. O could be followed by an I. So it'll be E plus O here. O, modulus of that. E O new. We know that the only thing that precedes an O would be the precedes an O, I should say. So an O. So none of these have O's except for not I would be including O. So it would be an I. So anything following an I would be an O. So it would be I modulus. And then U. We have new U, which would be anything following having a U on the side. It would be O and then I. So IO plus O. And take the modulus as well. Alright, so now what we want to do is reassign our old A. Well, I'll just copy it. It might be easier. Our old A, E, I, U, O, U to our new ones. A, new, E, new, I, new, O, new, U, new. Alright, and we want to return, what do we want to return? We want to return the count return, ask how many strings of length n can be formed. So we return the count of possible permutations. So that would be the sum of all the a, e, i, o, u that's equated to nu. So it would be a plus e plus o, I plus o plus u. And we'll take the modulus of that too, just in case. Well, alright. Let's see how this goes. Alright. What am I doing here? Oh, in range. Alright. This is unpacking. What am I doing?